You've kind of taken responsibility for that, and Aiden appreciates it. Okay. Good morning, good morning, good morning. Last we left was Thursday, and I had talked about going to an AP conference, correct? Am I right? And I started at 6 a.m. I got there, arrived 8:15 a.m., correct? I went 73 miles. Does this look correct? Yep. Did we create ordered pairs? Were we looking for average rate? Did I say anything? Average speed? Yep. What? Average speed, average rate's the same thing. So speed's absolute value. Okay. Did we figure it out? Did I say what's another name for average speed? Slope of what? Secant line. You absolutely need to have that burnt in your head, correct? How many points do you need for slope of a secant line, Jack? 2. So let's come up with 2 points here. Jack.
So you do 6 and 0.
6 and 0. What's 0 stand for?
Just starting 0.
What?
0
I've gone 0 miles at 6 o'clock, correct? Okay, what about over here? What's my other point?
8.25.
8.25, because 15 minutes is a quarter of an hour, and I went how far?
73 miles.
Okay, so slope of a secant line, how do we figure that out? Yeah, you're on a roll.
Okay.
I want to keep this going. No, just how do we figure out slope of a line? We got 2 points. What do we do now?
I think it's so obvious I'm just blanking.
Okay, slope formula. Okay, what are my y's?
73, 0, so.
And what's my x's, right? So you're doing y2 minus y1 over, yeah, what's this down here?
8.25.
8.25 minus, and what do I get? What's 73 minus 0?
73 over 2.25.
Okay, now we actually have to go to a machine, right? Does anybody have a machine? Elijah almost must have it figured out already. You just waking up? I had a great night's sleep. I slept through the entire night. Went to bed at 11:45, got up at 4:30.
Do you have an extra note packet?
I have one right here. Were you gone? Anybody have this? 32. What? What's my unit? Miles per hour. Correct? It was, Caitlin, painful. Really painful. And this is my average rate. Correct? Now the way this happened is at 6 a.m., I go in the garage, I open the garage door, I start the car, I back out, get onto our cul-de-sac, stop, go to the stop sign, take a right, stop a couple more times, and then get on the freeway, correct? Now, my distance, I'm going to call d of x, is differentiable. That means I can take the derivative of it. And thus continuous. there must have been a time, an instant, where I was driving 32.4 repeating miles per hour. Right? At least one time. Wouldn't you agree with that? There are multiple times because I came to a stop on my way there, Landry. And when I was going by Monticello, I was going 70. And when I got to, you guys know where the Albertville Mall is? I wasn't. I was going 20 for a long time. And then I got in 694, and I was back up to 70. And then when I got on Cleveland Avenue, I wasn't. I was going 10 miles per hour. There were even moments when I got onto Cleveland Avenue, I came to a complete stop. Okay? So there are multiple times. What do you suppose this was? There must have been a time, an instant, where I was going 32.4 miles per hour. What is this rate? What do I call this? If this is the slope of a secant line up here, right, where I have two different times. I have my starting time and my ending time, correct? Gave me my average rate. But the moments that I'm going 32.4 miles per hour during my drive, what do we call that? I can hear you barely.
Tangent line.
What of the tangent line?
Instantaneous rate.
Instant rate. Okay? What's another name for instantaneous rate?
The slope of the tangent line.
Slope of tangent line. So we're going to talk about those moments where the slope of tangent line equals slope of secant line. Okay, Denise is going to ask you some big questions. Okay, how many points do you need to figure out the slope of a secant line? 2. Okay, and how do you figure them out? How do you figure out, how do you use those 2 points? You know, like Jack, he came up with these 2 points, right? And we figured out the slope of the secant line, which was 32.4 repeating, right? That was my average rate. How did he figure them out?
By using the slope formula.
Okay, which looks like what?
y1 minus y2 over x2, or x1 minus x2.
Perfect. So I'm going to write it this way. F of b. That's going to be my y value when I put b into it. Minus f of a. That's going to be my y value when I put a into it. y1, y2, y2, y1. Doesn't matter. One of them's the y's. They're 2 different y's. Okay? Down here I'm going to have b minus a. Would you agree?
Yep.
x2, x1. If this is y1, this is x1. Correct?
Yep.
Okay? That's the slope of secant. How many points do we need to figure out the slope of a tangent line, Denise? 1. And what do we do with that 1? We put it into the what? You've done very well.
I can't think of the
Okay, I'm going to ask Alexis. Okay. This is a slope of a secant line. Would you agree?
Yes.
How would I write the slope of a tangent line? What do I do to figure out the slope of a tangent line?
And it would be y over x, so c over, or f of c over c.
That's how we figure out the slope of a tangent line? What's another name for slope of a tangent line besides instantaneous rate?
Derivative.
The derivative. How do you figure out the derivative? How do we show that we're figuring out the derivative? If my function's s, what does if my function is f, what's my derivative?
F prime.
F prime. Okay, we have all these rules how to figure out f prime, right? We only have one way to figure out the average rate. Would you agree with that? Only one way. Here we have a whole bunch of ways. We have the product rule, we have the quotient rule, we have the power rule, we have our trig rules, and they go on and on and on. Chain rule, right? Here one way. Here more than one way, right? Do I put a into here? In other words, at 0, 0, was that where my instantaneous rate was? Was it at 8.2573? Where was it? Somewhere in between, correct? So I got to have a letter that represents somewhere in between. What letter do you think we should pick? C. And we know C is somewhere in between A and B. And can there be multiple C's? Yeah. There could be C1, C2, C3, C4, C5, because in my drive, there were multiple times I was going 32.4 repeating miles per hour. But it didn't happen at A and it didn't happen at B, did it? Somewhere in between. Is that making sense? There has to be. This is called the mean, because it's associated with average rate, mean value theorem, where the derivative is equal to the slope of a secant line as long as C is in the interval A to B, and they should not be closed, they should be open, because they can't be A or B.
We can't.
Hmm?
We can't see.
Can you see now?
Yes.
Okay, so let me go to the official note document, which is only one page. Notice there is no quiz tomorrow. I'm going to try to give you a work day. I moved the quiz to Wednesday. Hopefully you guys got your Desmos activity done for today. Okay? Let's say f is continuous on a closed interval and differentiable on an open interval. Aiden, what do you suppose differentiable means? That I can take the derivative on any point from A to B. I can take the derivative. That's what differentiable is. Then there exists a C in this interval such that this should be f of C. So this is the slope of the secant line. Excuse me, slope of tangent line. I misspoke. This is slope of secant line. So here we're saying the slope of the tangent line is equal to the slope of the secant line. Let me give you a beautiful picture. Here's A. Right here is A comma F of A. Here's B. This is B comma F of B. You know what that is? That's F. That's my function f and how it goes through A and B. And I'm going to draw a line. I'm going to connect the dots, just like I did when I was a kid. Well, I don't think Perkins existed when I was a kid. Jack, what is that green line? It's the secant line. And it has slope, right? So I can use I should not have put this away. I can use this straight edge and I could try to make a line parallel to it. Does that look parallel? That's pretty good, isn't it? Right? Didn't you guys do that in Desmos? And right here, what is this point right here? It's C comma F of C. And it has the same slope as the green line. The red line and the green line have the same slantiness, don't they? And if I go straight down, right to here, what's my x value? C. And is C between A and B? It has to be. Now, Aiden, how do I know F is differentiable right now, just based on my graph? I'll make it big. How do I know this is differentiable? What? It has an infinite number of tangent lines. But that's... Are all graphs differentiable?
No.
Okay. Can I show you a graph that I know is not differentiable? That one's not. That one's not. You know how it is? How I know that is? It comes to the sharp point, right? Right? If I looked at the tangent lines as they approach from the left and the right, they're headed towards a different number, aren't they? Isn't this a positive slope? Isn't this a negative slope? And isn't this becoming more negative and this becoming more positive? Do you see that? Well, how can if one's going to positive infinity and the other one's going to negative infinity, will they ever meet? No, they'll never be the same number. But let's look at this beautiful graph. What can you tell? How do I know that's differentiable, Aiden? It has a smooth curve. There are no sharp points. You could take your hand and run your hand over that like I do in the morning when I shave my head, and my head feels smooth. I know I'm not going to poke my hand. Does that make sense? This is called the mean value theorem. This is what it looks like as a picture. This is what it looks like in calculus. This is the calculus part, correct? And it's equal to this part, which is, I don't know, when do you guys learn slope? Like in 7th grade? Yeah. So this is 7th grade. This is high school, right? Calculus. But I have two scenarios. I have this graph. I'll back it off a little bit. I have this graph, and I have this calculus, and I gave you an example of me going on to a meeting on Wednesday, right? You've been there. How do I know that? Because as a child you were bored and you said, Dad, are we there yet? Mom, are we there yet? And then all of a sudden you get a traffic jam, you go, oh my God, I think I'm going to die. I am so bored. And you probably weren't allowed to punch your brother. Jack, do you have a brother? Are you an only child? Do you have a sister? Oh, you've got to punch your sister, don't you? You're a non-violent person. That's good. You've never been angry at your sister once.
Yeah, like we fight.
Not physically fight.
I mean, sometimes not like punch.
Kick?
No,
Bite?
no, it's not.
Rip out hair?
Nope.
Light them on fire? So, but what has to be true? F is differentiable, no sharp points, like Aiden said. Okay? And C is in between A and B in that open interval. Math geekness, geometry, again, another real life situation. Instantaneous velocity, slope of a tangent line. Average velocity. Instantaneous velocity is at a moment. Average velocity is between A and B, right? Okay, true story. Julia, 2 stationary patrol cars equipped with radar are 4 miles apart on Highway 52 south of Cannon Falls. That's how you got to get to Rochester. That's how you have to get to Plainview, Minnesota, if you live in St. Cloud or Bemidji. As I pass the first patrol car, my speed is 60 miles per hour. Denise, the speed limit is 65. I'm well under the speed limit. Well under the speed limit. No ticket for Kruger. 3 minutes later, when I pass the second patrol car, my speed is 57 miles per hour. Ryan, I'm going even slower. Because I do what everybody else does. Oh my gosh, there's a patrol car. Step on the brake. Right? However, proving that using the mean value theorem that Mr. Kruger exceeded the speed limit. How is that even mathematically possible? Of 65 miles per hour. I have photographic proof that I'm going 60 and 57. So, mean value theorem. First thing I need is a slope of a secant line. 1. Slope of secant line. How many points do I need, Julia? 2. Caitlin, 2 points. What's one of those points, do you think?
60, 0.
No. See, this is a tricky problem. See, this is what happens. They got this gun. They're pointing at you like this, and in the other hand, they got a stopwatch. And they're talking to their buddy. And they say, and the other guy's got a speed gun and also has a clock. Okay? And so when they go like this, and the reason I know this is my roommate is a cop. He's a retired cop now because he retired. Okay? We sit there and point, and then they go click at the same. They'd say start, and they go start, and the clock would start going on. Okay? Because they know how far apart they are. So what do you think, with that scenario, what do you think my point is? My first point. The clock starts. Not sure? Let's ask somebody. Somebody think they know? I thought I heard a whisper. Because no one wants to say it out loud. Landry.
Is it 0? It's 0.
0 what?
Well, it's time 0, 0.
0, 0. So this stands for time. And this stands for distance. Caitlin, do you know what a red herring is? Sometimes people call them rabbit holes. Does anybody ever hear those? Ever hear a red herring? It's a fact that is not helpful at all and leads you in the wrong direction. It's a red herring. 60 miles per hour and 57 miles per hour are red herrings. They're not helpful at all. So if this is time and this is distance, and that's my first point, what's my second point, Elijah?
Wait, 3, 4.
3, 4. What's 3?
The time, like 3 minutes.
It's 3 minutes.
And 4 is the 4 miles.
4 miles. So when I compute that using, okay, you're using the right information. Okay, so here's my question. When I use that to figure out my average rate, the slope of a secant line, what's my units of measure? Does everybody agree? 4 miles, right? 3 minutes. What's my unit of measure? Miles per minute. Does the sign on Highway 52 say miles per minute? MPM. No, we got a problem there. It's miles per hour, correct? So I got to change that. This is equal, well, 4 miles I'm not going to change. I got to change 3 minutes into an hour. 3 minutes is how much of an hour? 1/20th of an hour. Is everybody okay with that? Owen, tell me how to figure out my average speed.
You use the slope formula.
Yeah, tell me what to rate.
4
4 miles.
minus,
Oops, sorry, I wrote 40. Minus 0.
yeah, over 1/20th minus 0.
And this is hours, correct?
Yeah.
And I get 4 divided by 1/20th. What is that?
80 miles an hour.
That is 80 miles per hour. That's my average rate in 3 minutes. That's my average rate. What does that mean? Julia, I was booking it if my average rate is 80. Right? So, now this is what I have to say. I'm going to write it right here. Because, of course, I didn't leave myself any room. See, this is my work. This is my work right here. That's what they're going to look to see that you did. So I'm going to say since. Now, what they'll tell you is something is differentiable. Since d of x, distance, excuse me, d of t, sorry, d of t, distance Kruger traveled, is differentiable, and therefore continuous, because if it's differentiable, you're guaranteed it to be continuous. I'll say it again. If it's differentiable, you are guaranteed with the housekeeping seal of approval, guaranteed that it's continuous. You cannot draw a differentiable curve without it being continuous. It's impossible. Okay? If it's differentiable and continuous, And I don't want to say that. There must be a time, what? T in what? Where's my time have to be in? 0 to what? 3 minutes or 1/20th of an hour? Where d prime of t equals what? Equals what? 80 miles per hour. Exceeding the posted speed limit then I always end with this, by MVT. So I need to have that as continuous and differentiable. I need to have to state that somehow there must have been a time where I was traveling 80 miles per hour by MVT. Does that make sense? Now, there are certain functions that are always differentiable in their domains. Remember what domain is? It's only those numbers that get invited to the birthday party, correct? All polynomials invite all children to their parties. Does everybody know what a polynomial is? It's where your exponents are positive integers. Okay, rational. Again, it's the domain, because the ones that make division by 0, they're not invited. They're problematic. Radicals. We're not able to put in negative numbers if they cause problems, correct? All trigs except for those that cause division by 0. Does that make sense? Backside. Rolle's theorem is just a special case. So here's the idea. Notice it says f of A equals f of B. So I'm going to draw a graph. Here's A. Here's B. Here's f of A. That's that y value when I put A in it, correct? It's got to be equal to f of B. Well, what does that mean about this y value right here? Allison, it's got to be what? They got to be the same, correct? And it's got to be continuous and differentiable. Well, if it's differentiable, it's continuous, which Aiden would say, hey, it's got to be a smooth curve. So there's my smooth curve. Right? Now, I'm going to draw in the secant line. Oh, I'm going to use blue, Allison. Okay, I'm going to use blue. There's my secant line. So in other words, I have this. Leave my blue here. That secant line is f of B minus f of A over B minus A. But Landry, f of B and f of A are the same y. So they could be 4 minus 4. They could be 7 minus 7. They could be a negative 20 minus a negative 20. What do you get? 0 over B minus A. What is 0 divided by B minus A, Landry? 0. It's a horizontal line, correct? Which means I've got a tangent line, since it's differentiable, that's parallel to it, correct? It also has to be horizontal, correct? Meaning that this point's got to be a what? A turning point, doesn't it? This is where my C is. My C is a critical number. My C is a critical number. This has got to be an extrema. Extrema means points. Critical numbers are x values. Somewhere between A and B, I have to have a critical number if these two are the same. Right? That's Rolle's theorem. What an easy theorem. And he got a name. He got to name that after himself. I have a Kruger number. I'm the only one knows that it exists. It took me 3 notebooks and 3 years to figure it out, but I have it. I might show it to you someday. Alrighty, so this is hard to see. Okay, it says this. Determine, now this comes from your homework. So rather, look at your notes when you do your homework. Determine if Rolle's theorem can be applied to f on the interval a to b. If yes, find all the values of c in the open interval a to b such that its derivative, I should write this is wrong, f prime of c equals 0. Okay, that's what it should say. Well, f is differentiable. Correct? Why? Since f is a what? Justin. What is x squared minus 2x?
Polynomial.
Is a polynomial. F is continuous. Since f is what, Justin? Starts with a D, since it's differentiable. So the last thing I have to do is prove that f of a equals f of b, correct? Justin, what is a in my problem? 0. So if I put 0 into f, what does it give me? 0. What if I put, what's b? 2. What do I get when I put 2 into f? 0. Huh. So it has to work. Let's see, it's differentiable, it's continuous, and f of a equals f of b, correct? So we should be able to find a c that gives you a slope of 0, right? So what is the derivative of f? 2x what? Minus 2. So now I'm going to plug c into here. I'm going to let it equal 0, correct? Right? Everybody see with that? You're going to let it equal to 0? And you're going to solve for c, and what are you going to get? 1. Is 1 between 0 and 2? Yeah. So what does this graph look like? Well, here's 0, 0. Here's 2, 0. Right here is 1. Oh, I don't have a y value for 1. What am I going to do? Oh, plug it into F. What do I get when I plug it into F? Ooh, I need a -1 right here. Right here. I got a smiley face. What does that mean? 1 comma -1 is an what? This graph, what are you guaranteed to say about 1, -1? What is it? More, what kind? Absolute minimum. All the other y values are bigger, correct? Everybody agree? All right, Owen, I want to draw this next picture. Can you see it? No. You know, that was very subtle. I like that. That was really cool. That point is 1 comma 1. Okay? -1, 1, sorry. This point right here is 2 comma 2. Okay? On everything okay? The orange line, what is it, Owen? Okay, so on the AP exam, they ask you to say, they give you 2 points and they ask you what is the slope of the secant line, or they ask you for the average rate or something like that, okay? And then they ask you this. Explain why MVT does not work in this problem. Now, what do they mean by that? That means that a tangent line, can I come up with a tangent line that's parallel to this, right? That's a secant line, right? That's a secant line, that's a secant line, that's a secant line. Is that where my tangent point is? No, because I'm either got to be here, correct? Or I got to be here. So can I use the mean value theorem? No. But then they ask you to justify. Why can't you? What would be your reasoning to get all 9 points?
It's not differentiable.
At
X equals
x = 0,
0.
correct? It's not differentiable within the interval from -1 to 2. Does everybody understand that? Why is it not differentiable? Yeah, and what you'll have to say is the derivative as you approach from the left is different than the derivative as you approach from the right. That's what causes sharp points, okay? And if you look at this, the derivative over here as you approach from the left is a -1. The derivative of here as you approach from the right is a +1. Yep.
How would you prove that?
How would I prove that? You don't have to. They'll give you a graph, and they'll you could say sharp point, but then simply say sharp point, and I know that because the derivative as you approach from the left is different than you approach from the right. I guess what I could do here is I could say the limit of this side, the limit of x as it approaches 0 of f prime of x is equal to a -1, right? You would agree with that? Because that's a straight line, okay? And the I got to have left here, sorry. And the limit as x approaches 0 from the right of f prime of x is a +1. They're not the same. And they'll do things like this. They'll give you points like this. And so this point might be 1, 3. This is 0, 0. And then they have over here, they'll have 4, 0. Okay? And they'll ask you, why doesn't Rolle's theorem work in this case? Well, because the y values are the same here, right, in that interval. And so, okay, are you going to be able to find a point there? You can't. So Rolle's theorem doesn't apply in this case because it's not differentiable at 1. Because the limit here would be 3, and the limit here, you know, the limit of the derivative here is this slope. Okay? And whatever this slope is here, a -1, I guess it would be. Okay? And you don't have to write it out like this. You can just say, hey, the limits are different on the left and the right of the derivative. They're really looking for your own words. Does that answer your question?
Yeah.
Okay. Alrighty.